Hey guys, Mr. B here again, bringing another math video. If you find this video helpful, feel free to like, share, subscribe. This video is going to be about linear inequalities in two variables. So you've probably done, if you're looking at this video, you've probably done linear inequalities in one variable, and that's not much different than solving an equation. Linear inequalities in two variables is really not that different than actually just graphing a line. So that's really the most important skill to be able to do here, is graph a line. So whatever way you want to do that, totally up to you. So if it's y equals mx plus b, slope point form, finding 2 points, finding the x and y intercepts, which is my personal favorite, that's what I'm going to do for this first one. The second one I'm going to do with y equals mx plus b. So that's what the first thing you need to do is really decide how you're going to graph it. So we need to graph this inequality in line form. So really what I do is, first of all, I just think about 3x plus 9y is equal to 18. So I have to graph this line. So I'm going to do it with x and y intercepts. So first of all, I'm going to find the x-intercept first. And I'm going to do that by letting y equal 0. So if y equals 0, this entire part goes away. So I'm left with 3x is equal to 18. Then I divide both sides by 3. So I get x is equal to 6. So I get an x-intercept of 6, 0. So there's my first point. All I need to graph a line is 2 points. The x and y intercept just happen to be special points. So my y-intercept, I let x equal 0. So when I do that, this part goes away. So I'm left with 9y is equal to 18. So that leaves me with divide both sides by 9. So then I get y is equal to 2. So what I can do now is write up my other point. So 2, 0. Oops. Scratch that out. 0, 2. So I plot both of these points. So 6, 0 is right here. And then 2, 0. Or 0, 2. Sorry, I keep saying 2, 0. 0, 2 is right there. Now what I need to do is graph my line. The only thing that I have to be careful with is that these lines aren't always solid. So if I look at this guy, anytime you have just greater than or less than, it's going to be dotted. It's going to be a dotted line. So the reason being is because if I have a point exactly on this line, so for example, 0, 2 is exactly on this line. If I put 0, 2 in here, x equals 0, that goes away. 9 times 2 is 18. Well, 18 is not greater than 18. So it's technically not a solution. So a dotted line would represent that the line itself is not a solution to the inequality. So if I have these guys, then it will be a solid line. So all I got to do is connect up my 2 points. I'm going to use a solid line at first, then I'm going to change it to a dotted line. Well, I'll just use this line tool first. I'll change it, hopefully. So let me see if I can get this correct. There we go. So I'll just drag this guy out here a little bit. So I can get some properties of this line. Not seeing any properties here, guys. So I'll just see if I can. I'll just draw another line. Even though it has an arrow on it, should have an arrow on both ends. I'll draw an arrow on both ends anyway. So let's see. Sorry about the delay here, guys. It happens. So there's my line. And I'll get a black marker out now. Pens. And I'll draw an arrow on this end just to make it match. So there's my line. Now the only thing is that linear inequalities in two variables have what's called a solution region. So a part of the graph where either above or below is where all the solutions lie. Basically, points that make this inequality true. I'm just going to extend it so I have it a little bit beyond there. There we go. So points that make this inequality true. So what I like to do is I like to pick a test point. The best test point is 0, 0 generally. So my test point, and some guys you can kind of look at this without picking a test point, but I like to pick a test point and I like to write out that working. Just a systematic way it works every single time. So if I sub in 0 in here for each one of these, so 0, 0 plus 9, 0 is greater than 18. So that if it's true, that's where it's a solution. If it's not true, then it's not a solution. So obviously 0 is not greater than 18. So we can put a line through this to make sure it's that, and this is false. So that means that 0, 0 is not a solution. So that means that everything, the solutions must lie above the line. So then what I can do is I can just take my pencil and just shade in above the line. So this is all the solution region right here. So I can just show you, I can pick a point here. So this point right here is 0, 5. So if I put 0, 5 in here, so 9 times, so this guy goes away, 9 times 5 is 45, is greater than 18. So every point in here satisfies the inequality. So let's do another one in a slightly different way. So let's do this one by solving for y. So this would be changing it to y equals mx plus b form. This one doesn't lend well to, actually it does lend well to x and y intercepts actually really well, but that's besides the point. So let's rearrange this for y equals mx plus b. So again, I'm going to get rid of the greater than sign, and just all I need to know for that is really I'll check that back in. I know my line's going to be solid this time because we have the equal to part, but I'll check back in with that less than sign when I do the solution region. So we have that. So I'll solve this for y, so I'll subtract 2x on both sides. So I have 3y is equal to negative 2x. And guys, if you're in this, doing this, I would assume you've dealt with y equals mx plus b many times. Then I'll divide everything by 3. Y is equal to negative 2 over 3x plus 2. So I divide both of these things. So 6 divided by 3 is 2. Negative 2 divided by 3 is negative 3 over 2. So this is my y-intercept. So that does get us the y-intercept, which is right there. It's 2. And I'll use this slope. So that slope of negative 2 over 3, that means 2 down and then 3 right. So I go 2 down, 1, 2, and then 1, 2, 3. So I end up with the x and y intercepts anyway, which are pretty good numbers. So now I'll connect those up with line. So there it is. I like to extend my line beyond my graph guide, especially when you're doing a solution region. It just makes it look a little bit nicer. There it is. So let me see. Pens, black line. So I'll put the arrows on the end there. And then what I want to do is I want to pick a test point. So again, 0, 0 is a good point. It's far enough away from the line. So my test point is 0, 0. So now what I'll do is I'll go ahead and put it in my inequality and see if it works. So I have 2 times 0 plus 3 times 0 less than or equal to 6. Well, that's going to be 0 is less than 6. So that is true. Therefore, this is my solution region where that test point lies. So if that little inequality is true, then that's my solution region. If it was false, I would shade the other side. So there it is. You can probably do a little bit better job if you're shading with a pencil. But there it is, guys. That's how you actually find solution region. I'm not too happy with that. Let's see if I can find a better pen. Yeah, let's use a highlighter. Yeah, so you highlight the region, make it look kind of nice. Like I said, if you had a pen or something like that, or a pencil, you could shade it in really nice. Alright guys, there it is. Thanks for watching. Like, share, subscribe. See you guys in class.